Hey, this is a tutorial for the sixth exercise for Grasshopper, and it's named Spheres Relative to Height. It has to generate randomly positioned points in a box volume, and then use these points as centers for spheres that have a size or a radius that is relative to their height. So let's do this. First, let's generate the randomly positioned points within a box volume. To do this, we're going to go to vector where the point components usually are, and at grid we can find this one, populate 3D. This component generates randomly positioned points within a box volume or parallelepiped. In here, the count is how many points it generates is 100. We can modify this using a slider, let's say 88, and input this to count, and now we have less points. And the region, it has a box already defined. If you want, we can modify this. As usual, we find the box at surface, the box components at surface and primitive. And we can use, for example, the main box. And the main box uses domains as dimensions for its size in the three directions, x, y, and z. Domains are basically ranges of numbers. So, for example, for x, it has a default value of -2 to 2. And if we look from above, we can see that this box extends from -2 units to 2 units in here. Okay. But if we input there a simple number, let's say 4, then we will get Grasshopper transforms that number into a domain that is from 0 to that specific number, in this case 4. And let's say we can use this for the first 2, and then use another one, maybe, I don't know, 11 or something, for the other. Okay, this is just playing around with boxes, or it's just showing another way to generate a box. So now we have the points, and we want to do spheres. Spheres we can find again at primitives, so surface, primitive, shapes, sphere, and we can use these points as basis for the spheres. And now we have all these spheres, but the exercise needs us to make their radius relative to their height. So in order to do this, we first need to get the heights for all these centers of spheres, so meaning all these points that got generated randomly. In order to do this, we're going to use a component that you can again find at vector where the points are. And here at point we have this one. The icon is quite suggestive. It's named deconstruct. It should be named actually deconstruct point. And it outputs the 3 coordinates for the points. And we need the z coordinates because those are the ones for the height. So these are the z components, the z coordinates. You don't actually need this panel. I just wanted to show you what these are. And if we input this directly into radius, we will get some very big spheres. I mean, some are big because the radius of the sphere is the same as the height, meaning that all these spheres are tangent to the base plane. But we don't actually want this. We want them to be somewhat smaller, so let's just multiply this with a factor. So to multiply this, we go to math, multiplication, and multiply this by, let's say, 0.11. Enter. And now we have a number slider with that value. And we can also play around with that value. Maybe I should make this not be visible anymore, but as you can see, the higher the sphere, the larger its radius. And we can make this even bigger or smaller as we wish. And that's about it. You should be careful if you have points that have z value below 0. So let's say -2 or something, they are below this base plane. They won't be very small because that number, let's say -3, if you input that into radius, it becomes actually a positive value. So it will have a radius. So if this box is not above ground level, then in here you will get spheres that become larger, even though they're lower. And that's about it. So just make the box in here higher than the ground, or starting from that ground.